Yo, welcome again. Let's do it. Today, we are going to talk about the standard deviation. Did I make this video right after the percentiles video? Or do I just not change my clothes? Who knows? Who cares? Doesn't matter. Yeah, so let's learn some stats. So we've talked about a couple measures of spread, right? We know what the range is, max minus min, kind of the rough estimate of the width of the entire data set. In the last percentiles video, we started to learn what the IQR actually measures, another measure of spread. And so now we want to look at our third measure of spread, standard deviation, and start to understand what is it. Before we jump into what the standard deviation is, there are a couple standard deviations we're seeing on our calculator screen. So SX, that stands for the sample standard deviation. And right now in this unit, we're going to be just summarizing a sample of data. So right now, we're only working with SX. Sigma X, this is the Greek letter sigma down here, this represents the population standard deviation. For now, we're not going to worry a ton about that. This is going to come up a bit when we get into statistical inference. We'll also touch on the difference between these when we start to understand the differences between samples and populations and get to our unit and talking about data collection and understanding the relationship between statistics and parameters. But for now, let's just find out what standard deviation is. So, standard deviation, measure of spread. Standard deviation, definition right down here at the bottom. Standard deviation measures the average distance a data value falls from the mean. So standard deviation is measuring, on average, how far is each data value from the middle, from the average. So standard deviation accounts for how far the data value is from the mean. Like, yeah, obviously, that's what the definition said. Why'd I even write that? So deviation itself, that word literally refers to the difference between the data value x and the mean x bar. So the deviation here, x minus x bar, literally represents the distance each individual data value has from the mean. And then this third bullet here, this is important. Standard deviation is the square root of variance, or conversely, variance is the same thing as the standard deviation squared. For now, we just need to know that definition, right? We need to know variance is standard deviation squared. We'll use variance later when we start to work with combining random variables and the Pythagorean theorem of statistics. And we'll also touch on what this means a little bit in a second when we do an example. Down here, we have the formula for standard deviation. Looks kind of crazy. I'm sorry, this is actually the standard deviation for variance, right? Because it's the standard deviation squared. We're about to break this down. So in the future, after this video, anytime you need standard deviation, like let's just pop the numbers in our calculator and let that do the work because it was expensive. But I think the best way we can strengthen our understanding of what this definition is saying and really understand what standard deviation is by doing an example and calculating it by hand. So let's do it. So here we have just a made-up data set, no context. Right now, we're not worried about context. We just want to focus on the math. So to calculate standard deviation, the average distance a data value falls from the mean. We've got this made-up data set. The average of this data set is 7. Here we just have the original data set itself, the original values. And so the first step, we want to find the average distance from the mean, is to find for each data value the actual distance from the mean, right? The deviation, or in other words, take each data value x and subtract the mean x bar. And that's what we're seeing here, right? 4 minus the average of 7. Here we're going to have a deviation of -4. Here we're going to have a deviation of 3. Of course, you can pause the video and finish this on your own. And 3 minus 7 is -4. So now, over here on this, here we have a bunch of deviations. So if we were in class, I'd ask you guys to think about this. So think about it on your own. Maybe say the answer out loud by yourself in your room. So our job is to calculate the average distance a data value falls from the mean. What might we do from here? Find the average. Oh yeah, these are all distances from the mean. So you know what? A pretty decent idea might be to find the average. Go ahead and try to find the average of those numbers in purple. What happens? So now that you've calculated it, right? When we add all these numbers up to start to find the average, -7, -4, 1, 2, 4, 0. We go to add these up, we end up with a sum of 0 divided by 1, 2, 3, 4, 5, 6, 7. Not that that matters, right? 0 divided by 0. But so we end up 0 divided by 7 gives us a standard deviation of 0. But that doesn't make sense, because to say the standard deviation is 0 is to say that the average distance from the mean is 0. Now think to yourself, what's the only way the distance from the mean could be 0, right? Like if I have a mean of 7 and then some data values, maybe I have 5 of them, what's the only way the distance from 7 is 0? What's the only way this distance from 7 is 0, or this is 0, or this is 0, right? The only way the standard deviation is going to be 0 is if this is a 7, and this is a 7, and this is a 7, and this is a 7, right? So standard deviation of 0 would suggest there's no spread, would suggest that all of these are the same number, are 7s. I apologize for the lag there. But we know that's not the case. So a standard deviation of 0, that doesn't make sense, because we can see some spread here, right? We can see they range from 3 to 12. Now think, why did that happen? Why did we get the 0? And in your bedroom, or whatever, your kitchen, maybe your garage, you're saying out loud, because we had some situation here where the positives and negatives canceled out. And that's always going to happen, right? There are always going to be some numbers above the average, which are going to have positive deviations. And there's always going to be some data values below the average that have negative deviations. There's no way the average could be below all of the numbers, or the average could be above all of the numbers, right? Then it wouldn't be the average. The average is a measure of center. So there's always going to be some positive and some negative deviations. So we're always going to have, right? It's not always going to be 0 exactly. I did that on purpose, probably, obviously. But we're always going to have that canceling out issue to some degree. And so the negatives are the issue. So what might we do here to get rid of those negatives? What? Oh, what'd you say? Absolute value. Or maybe you just ignore the negatives. That's the same thing as taking absolute value. So you might think, let's just make them all positive and find the average, right? We're talking about a distance from 0, and a distance is, right? We don't consider distances to be negative. So maybe we just take the absolute value of all these. And that's a great idea. And that's something called the absolute deviation. I don't know much about it because it's not going to come up in our course, or at least not for now. Or not in AP stats, but that is the thing, and that's a great idea. So absolute value, good idea. That's not what we're going to do here, though. What's another mathematical operation we can do that would make all of the values positive? And as you're thinking about that, we also can look at, remember, this is the formula for variance. So we have found all of the deviations. And so now, one idea to get rid of the negatives was to take the absolute value of everything. Another option is to square everything. And that's what we're going to do here. We're going to take all the deviations and square them. So over here are squared deviations. Now we're going to have what? 9, 16, 9, 25, 1, 4, and 16. And the reason we're doing that again, right, is to get rid of the negatives, right, kind of get rid of that canceling issue. So we found the deviations. We squared all the deviations. Now this, right, is telling us to take the sum. So we need to add all of these deviations. 16, 20, 21, 46, 55, 65, 71, 80. So these add up to 80. Let me just double check, right? 25 plus 25 is 50, plus 10 is 60, plus 20 is 80. All right, cool. So found the deviations, squared them, added them all up. Now this is telling us we want to divide by n minus 1. So we're going to take this 80 and we're going to divide by n, which is 7 minus 1. Now you might be thinking to yourself, I thought when we found the average, why? I thought we divide by the number of data values. Like, why wouldn't we divide by 7? Why do we divide by n minus 1? Great question. That's a great thing for you to Google and explore on your own. I think that's a good thing to research. That might be what I say when I don't actually know why it's n minus 1 at the moment. Maybe I should research it. But anyways, we're going to take 80 and we're going to divide it by 6. And then we're going to get, something. Why is this being such a pain, man? So we got 80 divided by 6 with the pressure of the video. That's too much for me to do in my head right now. I started to panic. So we get 13.33. But this isn't our standard deviation. We're not done yet because that shouldn't make sense. That shouldn't feel right. The average distance from the mean is 13, right? The average was 7. The biggest distance from the mean was 4, essentially, right? Or I'm sorry, was 5, right? So nothing was even close to 13 units away from the average. And that's because we're not done yet. This is the standard deviation squared. This is what we call the variance. So this variance, this 13.33 rather, that's the variance. So how do we find the standard deviation? Well, variance is standard deviation squared, which means standard deviation, solve this, is the square root of the variance. And so when we take the square root of 13.33, we get something. It would be helpful if I knew how to use my calculator. We get 3.65. And that seems a lot more reasonable, right? 3.65, that seems like a pretty good representation of the average distance from the middle based on those values. So that's how we calculate standard deviation. Don't do it by hand, though. We have like 75 numbers. I'm pretty sure if you're a statistician, someday your boss isn't going to walk in and be like, hey, can you find the standard deviation of these 5,000 numbers by hand on a piece of notebook paper, right? So we want to do it so we understand what standard deviation represents, but like use your calculator. All right, last slide. So thinking graphically, it's a good like multiple choice. We'll do some matching in class where we think about matching some summary stats to graphs. So comparing variability, comparing spread. So if we think about standard deviation, and I'm just making this up right here, right? We kind of think about which of these, maybe kind of make something bimodal-ish here, maybe make something pretty uniform. So the question I have for you, which of these, A, B, or C, you think has would have the largest standard deviation? Now, one thing that's important is I made these symmetric on purpose because since they're symmetric, that means the average is going to be about right in the middle. So that kind of simplifies our discussion here. So in any of these situations, which one, right? Remember, standard deviation is a measure of spread. Which one's the most spread out? Which one's the least spread out? So what do you think? Which has the lowest standard deviation? Which has the highest? Pause it. And hopefully for the lowest, you're thinking here, right? This has the lowest standard deviation. This data set is the least spread out. It's the most concentrated, clustered in the middle. Here, the majority of our data is pretty close to the middle, right? The tallest bins are close to the middle. These red lines, right, are all smaller deviations. There aren't many data values that have large deviations. So on average, most of our data is close to the middle, right? A small distance from the mean. So of these 3 graphs I've drawn, this would have the lowest standard deviation. What about the highest? Which data set shows that on average stuff is furthest from the middle? And hopefully you decided that this would have the highest standard deviation. This bimodal distribution, symmetric distribution, you would have a higher standard deviation here because here, the highest frequencies, the most data has large deviations, right? These tallest bins on the outside, these all have large distances from the middle, right? Whereas the stuff that's, right, there are low frequencies close to the middle. So on average, our data values are far away from the middle. So this is gonna have the highest standard deviation. Now C, right, it's gonna have a greater standard deviation than A because there is a good amount of stuff that has large deviations far from the middle, but there's also a roughly equal amount of stuff that has small deviations right close to the middle. And so that's how we can quickly look at a graph and kind of estimate which one has the largest standard deviation. I'm picturing an AP multiple choice where it gave like 5 dot plots, something like this. I don't know, I don't remember exactly, but it gave 5 dot plots and asked which of these has the largest standard deviation. We're probably thinking something like that. I think there was one that looked like this. And that's it. That's for the next video. Sneak peek. Have a wonderful night or day or morning or whatever. I just hope you have a great everything. Now you know what standard deviation is, so your life's a lot better.